Hi, I am Miriam Rateike.
And I am Ayan Majumdar.
And we are presenting our paper, Don't Throw It Away, the Utility of Unlabeled Data for Fair Decision Making. This is a joint work with Olga, Mineeva, Krishna, Gummadi, and Isabel, Valera. Let's start with a university admission example. First, individuals apply at a university. Then the university decides whether to accept or reject the applicants. For accepted applicants, the university observes their performance. But for rejected applicants, the university will never know how they would have performed. Let's say the university would like to automate this decision process while assuring that decisions do not discriminate individuals. In this kind of scenario, there are two types of biases present in the data: selection bias and label bias. Selection bias occurs when our labeled data is not an IID sample from the population of interest. And label bias exists if labels are influenced by an individual's sensitive attribute, like gender. Previous work, which we call FairLog, approached this problem as fair decision learning. To tackle label bias, FairLog proposes to use fairness constraints in their loss function. However, this explicitly trades off fairness for utility. This means we need to accept a lower amount of utility if we want to be fair. Second, FairLog tackles selection bias using exploration and bias correction. However, this leads to a high amount of variance and an unstable learning process. So we were thinking, can we perform better? We observed that FairLog only uses labeled data. However, in practice, we may often reject many more applicants than we accept. This means we throw away a potentially large fraction of the data.
In our work, we explored how we can use the unlabeled data to get rid of the fairness-accuracy trade-off, while also allowing for a more stable learning process. To this end, we propose a new policy framework called FairAll that uses both the labeled and the unlabeled data. But how do we utilize this unlabeled data? Well, instead of using fairness constraints like the previous approach, we first learn a fair representation Z of the observed features X and S using both the labeled and unlabeled data. Here, we rely on a conditional variational autoencoder. Then, like the prior work, we learn a stochastic policy. However, we take decisions based on the representation Z instead of the features X and S. We follow the previous approach in using online learning along with bias correction. But how does our approach perform in practice? Well, by tackling label bias with fair representation learning, we are able to get rid of the fairness utility trade-off. Importantly, this is only the case when the ground truth target Y is unbiased, meaning independent of the sensitive S. For tackling selection bias, we follow a similar approach to the prior work. That is, we also utilize exploration along with bias correction. However, we show how we can use the unlabeled data to learn exploring policies without the instability suffered by the prior approach. Thank you so much for your attention. Please have a look at our full talk, and for more details, check out our paper. We look forward to discussing our work in person at Seoul, or feel free to contact us online.